Good morning, children. Welcome back to the video classes. Now we are going to see the next question. The unit of permittivity of free space. Unit of. Okay. So next one, permittivity of free space. Okay. So what is permittivity of free space? That is epsilon 0. Epsilon 0 is the permittivity of free space. And its value is 8.854 into 10 to the power minus 12 coulomb square per Newton per meter square. Okay. So what is a unit? So coulomb square per Newton per meter square is a unit of permittivity of free space. Okay. So now we extend this question. What are all the units and the dimensional formula used in the first unit, that is in electrostatics. Okay. First one, charge. Okay. The charge is represented by Q. The unit of charge is coulomb. Okay. So what is the dimensional formula for charge? That is current is defined as rate of flow of charges. So the division time comes to this as multiplication. So IT equal to Q. Unit of current, ampere. Unit of time, second. Unit of charge, coulomb. So the equivalent unit of coulomb is ampere second. Now we can convert the unit into dimensional formula. Ampere as it is. Second, time. So capital T. So AT is the dimensional formula for coulomb. Okay, do you get it now? Okay, fine. The second one is force. Okay, so for force we can derive the formula in two ways. Okay, so by using the first lesson, we are going to see the unit and the dimensional formula for force. F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. 4 is the dimensionless constant. Pi is the dimensionless constant. Okay. Epsilon 0. The unit of epsilon 0 is coulomb square per Newton per meter square. Now, charge. Unit of charge is coulomb. Unit of charge is coulomb divided by square of the distance. So, meter square. Now, coulomb into coulomb. Coulomb square getting cancelled. Okay. Now, the denominator values goes to the numerator. So, power minus 1 goes to the numerator as plus 1. So, Newton power plus 1. The minus 2 goes to the numerator as plus 2. Okay. Now, this plus 2 goes to the numerator as minus 2. Okay. So, plus 2, minus 2 getting cancelled. So, anything power 0, 1. 1 into Newton. So, Newton is the unit of force. Okay. Now, we have to find the equivalent formula for Newton. Okay. So, for that, F equal to ma. So, the unit of mass is kilogram. Unit of acceleration is meter per second square. Is the equivalent unit of Newton. Okay. Now, convert the unit into dimensional formula. Kilogram, that is capital M. Meter, capital L. Second, capital T. Power minus 2. So, the dimensional formula for Newton is M.L. T power minus 2. Okay. Do you get it now? Do you have any doubts? No doubt. Okay. So, from the force, I want to go to the next one. Electric dipole moment. Electric dipole moment is denoted by P. The magnitude of electric dipole moment is defined as the product of magnitude of any one of the charge and distance between them. Okay. Now, the unit of charge is coulomb. Unit of distance is meter. Okay. So Coulomb meter is a unit of electric dipole moment. Okay, fine. Now the equivalent unit of Coulomb is ampere second meter. Okay. So this is a equivalent unit of electric dipole moment. Now convert it into dimensional formula. Ampere S, second T, meter L. So ATL is the dimensional formula for electric dipole moment. Okay. So from that I want to go to electric field. So electric field is defined as the force experienced by unit positive charge. Okay. So what is the unit of force, or what is the equivalent formula? Or from here we can take the value, that is kilogram meter per second squared. Okay. So kilogram meter per second squared divided by charge. Unit of charge is coulomb. The equivalent unit of coulomb is ampere second. Okay. So kilogram meter per second squared divided by ampere second. Okay. Now the denominator value goes to the numerator as inverse. So kilogram meter per second square. Now the plus 1 goes to the numerator as minus 1. In ampere, we are having plus 1. The plus 1 goes to the numerator as minus 1. Okay. Now convert this one. Okay. Now kilogram meter minus 2 minus 1. Minus 2 minus 1. So minus 3. Ampere power minus 1. Ampere power minus 1. Kilogram capital M, meter L, second power minus 3. So T power minus 3. A power minus 1 is the dimensional formula for electric field. So from the electric field, I want to go to the potential. Okay. So dV equal to minus E into dx. Okay. Or otherwise, V equal to V into L. Okay. So unit of electric field. Unit of electric field. That is kilogram meter second cube A power minus 1. Into length. So unit of length is meter. Now meter into meter. That is meter square. So kilogram meter square second power minus 3 A power minus 1. Now convert the value into the dimensional formula. Kilogram capital M, meter square L square, S power minus 3. So T power minus 3. A power minus 1 is the dimensional formula for potential. So by using the potential, we can go for the resistance. Okay. So V equal to IR. V equal to IR. Okay. So V. So what is the unit of potential? That is, the unit of potential is volt. The equivalent unit of volt is kilogram meter square second power minus 3 A power minus 1. Okay. So kilogram meter square second power minus 3 A power minus 1 equal to current. The unit of current is ampere. So the multiplication ampere comes with this as division. So kilogram meter square second power minus 3 A power minus 1 divided by ampere. Okay. So now the power plus 1 goes to the numerator as minus 1. So kilogram meter square second power minus 3. Already we are having A power minus 1. A power minus 1. So the power plus 1 goes to the numerator as minus 1. Minus 1. So that is a value of R. Okay. Now kilogram meter square second power minus 3 A power minus 2 is R. So the unit of resistance is ohm. Unit of resistance is ohm. Now convert the unit into dimensional formula. That is M for meter L square, for second T power minus 3 ampere. So ampere power minus 2 is the dimensional formula for the resistance ohm. Okay. So now the next one is electric flux. So pi equal to E into A. Okay. So now what is the equivalent formula for electric field? Okay. Electric field. Okay. So here kilogram, meter, second power minus 3, A power minus 1. Area. The unit of area is meter squared. Okay. So kilogram, meter squared into meter. Meter cube. S power minus 3. A power minus 1. Now convert the unit into dimensional formula. That is capital M, L power 3, T power minus 3, A power minus 1 is the dimensional formula for electric flux. Electric flux. Okay. So now we can modify this one. Unit of electric field, Newton per Coulomb. Unit of area, meter squared. So it can be modified Newton meter squared per Coulomb. Newton meter squared per Coulomb. Or otherwise, the equivalent unit of electric field. Equivalent unit of electric field. So the multiplication L comes with this as division L. So V by L equal to E. So unit of potential is volt. Unit of length is meter. So volt per meter is also the unit of electric field. So volt per meter into meter square. So meter and meter square getting cancelled. So volt meter is also the unit of electric flux. Okay. Do you get it now? Do you any doubts? No doubts. So the next topic is torque. So what is the formula for torque? That is force into perpendicular distance. Force into perpendicular distance. So unit of force is Newton. Unit of distance is meter. Okay. So what is the equivalent unit of force? That is, for instead of F, we can write F equal to ma. Unit of mass, kilogram. Unit of acceleration, meter per second squared. Okay. Here it is meter. Now, meter into meter, meter squared. So, kilogram, meter squared per second squared. Now, convert it into dimensional formula. Unit of kilogram, meter. Unit of length, L power 2. Unit of second, T power 5. The dimensional formula for kilogram is M. Dimensional formula for length, L. The dimensional formula for time, T. Okay. So, from that I want to go to electrical energy or electrostatic potential energy. So, first, energy. So, whenever we are saying energy, we are having two types of energy. One is potential energy, another one is kinetic energy. So, what is the potential energy? mgh. So, what is the unit of mass? Kilogram. G. What is G? Acceleration due to gravity. That is meter per second square. Unit of height, meter. Now meter into meter, meter square. So kilogram, meter square per second square. Okay. Now convert it into dimensional formula. Kilogram, capital M. Meter, L square. Second power minus 2. So T power minus 2. Just look at this. So torque and potential energy have same dimensional formula. Okay. Now we can go to the next one. Kinetic energy, that is half mv square. So half is the dimensionless constant. Okay. M is a mass, kilogram. Velocity, meter per second. Here we are having whole square. Now the square is common to first term and second term. So kilogram, meter square, second power minus 2. Kilogram, capital M. Meter square, L square. Second power minus 2. So T power minus 2. So once again look at this. So potential energy and kinetic energy having same dimensional formula and also the torque. Okay. So now how we can relate this one with the first lesson in electrostatics. That is epsilon equal to 1 by 4 pi epsilon 0 into Q1, Q2 by R. Okay, so 2Q, 1R. 4 is the dimensionless constant. Pi is also dimensionless constant. 1 by epsilon 0. So what is the unit of epsilon 0? Coulomb square per Newton per meter square. So Coulomb square per Newton per meter square. Now unit of charge, Coulomb. Unit of charge, Coulomb. Unit of distance, meter. Now take all the terms to the numerator. Okay. So power minus 1 goes to the numerator as plus 1. Power minus 2 goes to the numerator as plus 2. So here we are having plus 1. So plus 1 goes to the numerator as minus 1. Okay. Here Coulomb power plus 2 goes to the numerator as minus 2. Here we are having 1. So plus 1. Here also we are having 1. So it is plus 1. So Newton. 2 minus 1. 1. So 1 plus 1, 2. 2 minus 2, 0. So anything power 0, 1 into something, that something is Newton meter. Okay. Now, what is the equivalent unit of Newton meter? Okay. So here we are having Newton meter. So the same dimensional formula is also for electrostatic potential energy. Okay. So M.L. square T power minus 2. So what is this? Electrostatic potential energy. Okay. Now, these are all the physical quantities having same dimensional formula. Okay. Now, do you get it now? Do you any doubts? No doubts. Okay. So, next we can go. Number of electric field lines. Okay. So, number of electric field lines equal to pi equal to Q by epsilon 0. Or otherwise, when we are saying these two, we are taking these two, then it is said to be Gauss law. Okay. So the unit of charge is Coulomb. Unit of epsilon 0, Coulomb square per Newton per meter square. Now take all the terms to the numerator. Okay. So minus 1 goes to the numerator as plus 1. The minus 2 goes to the numerator as plus 2. Coulomb and Coulomb square getting cancelled. We are having 1. The plus 1 goes to the numerator as minus 1. Okay. Now, what is the equivalent unit of Coulomb? That is ampere second. Newton meter square ampere second power minus 1. So, the minus 1 is common to first term and the second term. So, Newton meter square per ampere per second. Okay. So at the same time, we can go for Newton also. So what is the unit of Newton? Equivalent unit of Newton. Kilogram meter per second square. Here we are having meter square per ampere per second. Okay. Now kilogram. Meter square into meter. Meter cube. So power minus 2 minus 1 minus 3 and ampere power minus 1. Now we can convert it into dimensional formula. That is kilogram, capital M, meter cube, L power 3, S power minus 3. So T power minus 3, A power minus 1, A power minus 1. This is the equivalent dimensional formula for number of electric field lines and also for flux. Okay. Now do you get it now? Do you any doubts? No doubts. So the next one is capacitance. So the capacitance of the capacitor is defined as the ratio of charge to the potential developed in it. Okay. Now, in the numerator, we are having charge. The unit of charge is Coulomb. The equivalent unit of charge is ampere second. Okay. In the denominator, we are having potential. The unit of potential is volt. Okay. So, V equal to E into L. So, what is the unit of electric field? Newton per Coulomb. Then, length, meter. The power plus 1 goes to the numerator as minus 1. Okay. So, Newton meter per Coulomb. Okay. Now, what is the equivalent unit of Newton? That is kilogram meter per second square. Meter. Okay. Coulomb. So what is the equivalent unit of coulomb? Ampere second. Ampere second. Power minus 1. Now, meter into meter. So, meter square. So, kilogram meter square per second square. Now, power minus 1 is common to first term and the second term. So, ampere power minus 1, second power minus 1. Now, minus 2 minus 1 becomes minus 3. Okay. So, kilogram meter square minus 1 minus 2. It becomes minus 3. Ampere power minus 1. So, this is the equivalent unit of volt. Okay. So, now we know the value of charge and also know the equivalent unit of volt. Then we can calculate the unit of capacitance. Okay. So, the unit of capacitance is farad. Okay. So, 1 farad equal to charge. Its unit is ampere second divided by volt. So, what is the unit of volt? Kilogram meter square. Second power minus 3. A power minus 1. Okay. Now, the denominator terms goes to the numerator as kilogram. Here we are having plus 1. So, plus 1 goes to the numerator as minus 1. So, the plus 2 goes to the numerator as minus 2. Okay. Now, the minus 3 goes to the numerator as plus 3. Numerator goes to plus 3. So, here we are having plus 1. So, plus 1. Here, a power minus 1. The minus 1 goes to the numerator as plus 1. So, already we are having plus 1. So, plus 1. Okay. So, kilogram power minus 1, meter power minus 2, 3 plus 1, 4. 1 plus 1, 2. Okay. Now, convert the unit into dimensional formula. Yes. So, m power minus 1, L power minus 2, T power 4, A power 2. So, this is the equivalent dimensional formula for 1 farad. Okay. So, the next one is a linear charge density. Linear charge density. Okay. So, what is linear charge density? Linear charge density is defined as the ratio of charge to the unit length. Now, the unit of charge is coulomb. Unit of length, meter. So, coulomb per meter. The equivalent unit of coulomb is ampere second divided by meter. The power plus 1 goes to the numerator as minus 1. So, ampere second meter power minus 1. Now, it is converted into the dimensional formula. Ampere, yes, as it is. Second. So, P, meter, length. So, L power minus 1. So, next one is surface charge density. Surface charge density. Okay. So, surface charge density is defined as the ratio of charge to the unit area. Now, the unit of charge is coulomb. Unit of area is meter square. Okay. The equivalent unit of coulomb is ampere second. The power plus 2 goes to the numerator as minus 2. Okay. Now, the equivalent dimensional formula for this one is ampere. For second, it is T. For meter. So, L power minus 2. Okay. And the final one is volume charge density. Okay. So, volume charge density is equal to rho by B. Just see that one. Q by L. So, L power minus 1. Q by A. Here, L power minus 2. Here, charge by volume. That is coulomb per meter cube. So, directly I go to the result. Okay. So, this ampere time L power minus 3 is the dimensional formula for volume charge density. Okay. Do you get it now? Do you have any doubts? No doubts.